Hi, good evening all. So I hope my voice is audible, right? Someone will respond. Am I audible? Yes, sir. Okay. Can you able to see my screen, right? So this live session we will see stack and queue data structures by using Python. So can you able to see my screen, right? Okay, fine. Okay, so I'll give brief intro about this stack and queue data structures. Then we will move on to Python, how to implement this stack and queue data structure using Python. Okay, so this is okay. What is stack? Okay, stack is nothing but a data structure. Okay, if you see here, first we will explain the stack data structures in simple words. Later we will see. Okay, so these are the stack of books. Okay, here we have so many books, like different colors. Here we have. We are trying to keep the books on one by one. Okay, on top of one book you are placing another book. Okay, so you are going to repeat this procedure. Okay, so if you are having any kind of structure like this, okay, you can call is this is as this. In this case, these are the books, so we are going to call it as a stack of books. Sometimes it may be some other items, but if it follow this kind of structure, you call it as stack. Okay, so we will see the basic definition for stack. What is stack? Okay, so stack is data structure of ordered items. Okay, so if you see here the previous example, is there any this will follow some order, or it's like unordered thing? So this is following some kind of order. Okay, so like one by one you are trying to place books. Okay, so whenever you say what is data stack means, so stack is a data structures of ordered items. Item means, so it may be books or it may be some other item. Item means it depends on sometimes. Okay, so for example you have some rack in your home, you are trying to place some items in the rack. Okay, so what you will do, generally you will place one item, after that you are going to place another item, so like that you will follow. Okay, so items means in real world entity, it may be anything. Okay, so that items can be inserted and removed only at the one end. So if you want to place some item, you want to follow, it will allow only one end. Okay, generally that end is called top end only. Okay, stack means always you need to insert or you need to place items, like in books also. Okay, so So what you are doing, you are trying to place one book initially, after that you are going to place another book. Okay, so what are what can you do with a stack? Now you have seen some basic definition for stack. Okay, so what you can do, for example, in previous case books example, stack of books. Okay, so you are trying to place books, or you are trying to remove books, or you want to look at means like search. Okay, which book is there in which place. Okay, so like this, these are called stack operations. That means what kind of task you can do with the help of stack. So these are the different tasks you can do. One is you can insert, or you can place one item on the stack. Okay, so that task is called, okay, like in data structure terminology we are going to use it as push. Okay, so the term for inserting or placing one item on top of one item. Okay, so that is push, or generally push operation. Okay, so if you want to look at so where is my book. Okay, if you want to identify, or if you want to find out um, so which item is there on top of the stack. Okay, so that operation, the task, okay, which you want to know what is the first item in the rack or you in the stack, you are going to call that operation as peek. Okay, then if you want to remove, okay, you want to look at one item and you want to remove it. Okay, that is called look at one item on the top of the stack and remove it. Okay, so that operation is called pop operation. Okay, there are mm, three different operations: push, peek and pop operation. Generally we don't use peek because the same task you can do it by pop only. Pop, what is the difference between peek and pop means? Pop, you can remove item also, but in peek you can't able to remove. Okay, so the most famous operations will be only push and pop. If you want, you can use peek also. So these are the different kind of tasks you can do with the help of stacks. Okay, now how this work, how it will work. Okay, generally this tag data structure, it will work in a LIFO manner. Okay, so LIFO data structure, the other name is LIFO data structure. LIFO data structure in the sense means, so like LIFO means last, I means in, F means first out. Okay, last in, first out. Okay, in stack, whatever the item you are going to insert at last, so you are going to remove that item as first. Okay, so the best example is, see here in this book example, so this is the last item you inserted. Okay, this is LIFO data structure. This is the last item you inserted in the stack. If you want to remove, okay, if you want to remove these books, first you need to remove this book, whatever the item you inserted at the last, you need to remove this first. Okay, last in, first out, this is the last in, the same thing you are going to take it out first. Okay, so that's why we are going to call this as stack data structure is LIFO data structure. Okay, so sometimes there is some other name is there, sometimes you are going to call this stack data structure is push down store. Okay, like whatever I told now, if you want to insert, the insert operation in stack is going to call it as push operation. So everything whatever you want to place one by one, so that process is called push down store. Okay, uh, then, so what are the different applications you can implement, okay, by using stacks, like your program execution. Okay, one of the best example, if you are writing some program, so generally what it will do, so sorry, this program execution, there will be a set of line by line statements are there. So I don't know whether you know this or not. In generally you are going to have some registers and stack data structure is there. Okay, whatever the program you are writing, so that program you are going to store in register, that registers are you are going to place in stack only. Okay, so whenever you want to operate, you need to operate that program register by register. That means you are going to place all those registers, okay, in the stack, then you can operate it. Okay, so the best application for stacks will be program execution and then parsing. Okay, parsing means the sequence of instructions, okay, whatever the lines of code you are having. Okay, so that you need to parse. Parsing means there will be some compiler is there in programming, you that compiler will take care of this parsing. Okay, then evaluating postfix expressions. Okay, I don't know whether you know this infix, postfix, and prefix and postfix operations. Okay, later I will show some examples. Evaluating postfix expressions, there will be some expressions is there like a plus b, okay, into c, like this there will be some expressions is there. This expression you can convert into a b c, and then you are going to add plus and star symbol. Okay, so such kind of expressions you are going to call it as postfix expression. Okay, so you need to evaluate such kind of expressions. This stack will be the best data structure to evaluate this postfix expression and infix expressions. Okay, so these are different applications. Okay, now we will see. Okay, so what is the different kind of problems we can face in stack. Okay, so for example, you assume that your stack, okay, uh, your stack is empty, like you have one rack in your home, you don't have any items in that rack, but you are trying to pick one item from the rack. Okay, so what will happen, without any item you can't able to pick any item. Okay, if there is some items are present in the rack, then only you can pick or you can select one item. Okay, so if you don't have anything, then you are trying to pick one thing, so is it possible? No, it's not possible. Okay, similarly in stack also what will happen is, so you are going to have different values, okay, or different items are there. So if you don't have any items, but you are trying to remove or you are trying to pick some items, then there is some problem occur. Okay, these are the stack problems. Okay, so what happens if you try to pop, you are trying to remove one item from the stack whenever the stack is empty. If no item is there, you are trying to remove it some item. Okay, so that condition or that case you are going to call it as stack underflow. Okay, so this scenario you are going to call it as stack underflow. So that pop method needs to like this is like in Java statement. Okay, this is called in Java we are going to implement some exception is there. I think we already discussed this exception thing. Okay, so like this is runtime exception. So when there will be no items are there, but you are trying to remove an item from the stack, in that case you are going to get stack underflow condition. Similarly, there is another condition that is called stack overflow. So what does this stack overflow means? So there will be like this is the code, like this is the different functions in Java. Okay, we will see Python codes later. As of now I am discussing some stack basics. Okay, similarly stack overflow means, this is underflow condition. Stack overflow means you are like the stack is full. Okay, that means your stack capacity is something. Okay, like you assume that there will be some 5 items you are going to place in the rack. Okay, the rack capacity is 5 items only you can able to place it, but what you are doing, you are trying to place more items, 6 or 7. Okay, but the capacity of your rack is 5, so this condition is called overflow. Okay, so if the stack is full, you are trying to insert or you are trying to push some element to the stack, so then there will be some problem occurs. That problem is stack overflow. Okay, so that is about the problems. The major problem is, one is underflow, another one is overflow problems. So then we will see one more application, a balance of braces. Okay, like stack or sometimes you are going to call it as I stack. A balance of braces, nothing but. So for example, if you observe, this is balanced braces, this is like parenthesis. So this is open brace and this is closed brace, this is balanced. Okay, whenever there is an open brace is there, if open brace is there, if you want to satisfy or if you want to call this as balanced braces means, then the opposite, okay, there will be closed braces will be present. Okay, then only you are going to call it as balanced braces. Okay, so here there will be two open and two closed braces are there, you are going to call it as balanced braces. So if you come to here, this is not balanced. Okay, because see here, this is balanced and this is balanced. Now here you come to here, so this is closed, this is closed, for this is also closed. When you take this one, here it is closed. Okay, these two are only closed braces is there, but there will be no open brace. Okay, so if you are having this kind of structure, this is not balanced. Okay, so where you are going to use this kind of um, things like braces and all, for example, you have some arithmetic operations, you want to evaluate some expressions. Okay, in that case you are going to use some braces. Okay, so these braces will help you to balance or to evaluate your expressions in your arithmetic and mathematical calculations or computations. Okay, so this is I stack. Then how can you use this I stack to check a brace is balanced or not? Okay, so when you want to implement the above requirement, okay, you ignore the implementation of the stack of like I stack, you just ignore it. The implementing is generally the stack implementation is you can do by using two small data structures. Okay, or two different data structures. So if you want to implement stack data structure, you can use either array or you can use linked list. Okay, so with the help of these two data structures you can able to implement the stack data structure. Okay, so we will see one by one. I think you already know array means so what is array? Someone will, what is array? Can you just give me the basic definition for array? So if you want to implement a stack, you can implement stack by using two ways. One are two data structures. One is array data structure, another one is linked list data structure. Okay, so array is a set of homogeneous or linear data structures. Okay, so it will present in a sequential manner. Okay, whatever the elements are there, that elements present, yeah, set of elements with having same kind of data types. Okay, with same name. Okay, yeah, correct. That is array. Similarly, linked list is there. Linked list means you can connect one list. Okay, a list by list. Okay, there will be some connection is there. That means item by item there will be connection. With the help of these two data structures, you can implement the stack. But which one is are good? What you can say? Which data structure among these two, array or linked list? Which one is better for implementing this stack? Can you just guess or can you say which data structure is good to implement stack data structure? Which data structure is good? Array. Yeah, okay. Someone is telling array. Basically, which one is good means it depends on your requirement. Okay, what kind of problem you are going to handle. Okay, it depends on the application or the kind of problem you are going to solve by using stack. Okay, so based on that you need to select array and the data structure. Okay, so We can't say whether array is better or linked list is better. It depends on the problem statement where you are going to, or the application where you are going to use stack. Okay, based on that you can select the data structure. um, so the next one is see here, if you want to implementing a stack by using array, so this will be okay. You already know what is meant by array. The bottom of the stack, okay, whenever we are writing stack elements, later I will show the that stack data structure also. So the bottom of the stack element you are going to call it as data of 0, okay. So then after that the top you are going to call it as the number of items minus 1, because you are starting the data elements with 0. Whenever you are starting, let us assume that, so the starting element is 0, you have 10 items, so the number of items is 10, 10 minus 1 is 9, okay. From 0 to 9 you will get the 10, okay. So always the bottom of the stack is like 0, then top will be n minus 1, or simply if you want to say number of items minus 1, okay. So that will be the top of the stack. Then you want to push on, like push operation you want to apply, then you can say data of that item, which item you want to push, data of 1 or data of 2 or data of 3, you need to mention that item, okay. So as of now I am discussing 0 1 2 3 like this number, but in real time it may be like some book numbers or some item numbers, okay, whatever it is, okay. So for our understanding, for easy understanding, we are taking some numerical elements 0 1 2 3 4 like this, okay. So if you want to push some item, you can represent like this, data of that item number. So if you want to pop, again the same structure, okay, whatever you have seen here. So the pop operation is like top of the stack only, whatever the item is present in the top of the stack, that item you need to remove it. For removing you can use pop function or pop operation, okay. So this will be using array. If you want to implement stack, you can take the data structures like this, data of 0, data of number of items minus 1, data of number of items and number of items minus 1, okay. So these kind of structures you need to follow if you want to implement stack by using linked list, okay. So you need to store, okay. So there will be some linkage will be there. I think, I don't know whether you know linked list or not. So linked list is like you have different kinds of linked list will be there, single linked list, double linked list, circular linked list. So what does it mean is, later I will show that structure of that linked list also. As of now you just try to understand. The top of the stack is head node. So in the linked list there will be two nodes are there. One is head node, another one is data node, okay. This head node is, you are going to take it as head node, okay. So these head node connections you need to modify, okay. So for example, if you want to push, okay, so what you want to do is you need to connect that head node to some front of the list, okay. So if you want to remove, you just remove that head node to that front of the list, okay. Like this there will be some operations are there, later I will show you, okay. So the another application by using stack is reversing a word. For example, you have a word, any word, okay, like you just take computer. So if you want to reverse the word computer, for to implement this kind of programs, stack is the best data structure, okay. So computer, if you reverse it you will get or, okay, e t like this you will get, okay. So this will be easy. Initially you need to store this computer word letter by letter, you need to push into the stack. Then what you want to do, then you can remove the letters from the top, okay, then you will get the reverse of the word, okay. So for reversing, stack is again the best application. So the another data structure you have, like what is queue, okay. So like you can see there will be some set of people, they are standing in a queue. Queue means like a kind of line, okay, sequential line. So again in queue there will be two ends are there, one is front end, another one is rear end, okay. So whenever you want to stand in the queue, this will be the end, okay, this is the end. Once here this is some hospital or some kind of reception in airport, okay. So this is the other end, okay. If their job is over, then they will get it out of from this queue, okay. So this is called like in stack you are going to use push and pop operation. In queue what you are going to call it as insertion and deletion, okay. So if someone is coming and they are adding here, this operation is called insertion. If the job is over, then they will come out of from the queue, then you are going to call it as deletion from the queue, okay. So this is queue, okay. See here what is queue means. Queue data structure, okay. It will be again the ordered items, such that only difference is you can insert only one end and removed at the other end, okay. So the best example is a line at the supermarket, or a line at the airport, or a line at the bank system, or a line at the ATM system, whatever it is, okay. So if you are having these kind of applications, you can implement these applications by using queue. So what can we do with queue? What can we do? For example, if you want to add one item, you are going to call it as NQ, okay. This is queue, NQ, okay. Like you want to insert it, right? For insertion, the name we are going to use that as insertion means like one end you want to insert, NQ. This is DQ means deletion, the short form is, okay. So remove, you want to remove some elements from the queue, you can say it as DQ, okay. So these operations also called like insert, or sometimes it may be get friend, in order to simplify, okay. So these are the queue operations, NQ and DQ. NQ is nothing but you want to add item to the queue. DQ is nothing but you want to remove an item from the queue. So stack data structure, it is going to work on LIFO manner. Q is FIFO, okay. So if you observe here, whoever will in for first, they will come out, okay. First in, first out, okay. She is the first one. She is trying to, this is the queue. She is standing in the queue first. She will come out first, okay. Like first come, first serve. So this will work, queue will work in FIFO manner. So what are the different applications you can do in real life, real time? See here, if you want to use, for example, your processor are there, like round robin scheduling in processors, okay. So this will be like operating systems. There will be some processors are there. Operating systems, they want to handle your programs or code based on some scheduling, okay. So round robin scheduling will work based on queue data structure. We can implement, okay. And then input output processing, then queuing of packets for delivery in network, okay, like internet something, okay. This is queuing of packets, okay. If someone is requested first some kind of data packet, so they will get served first, okay. So later based on that queue, it will deliver or it will serve the next person. Again this queue also, this queue data structure also you can implement by using two ways. One is using array and then using a linked list, okay. So if you are using an array to implement the queue, so it will be significantly harder than, okay. So when it comes to stack, both is having it will be there will be no simpler and harder thing. But when it comes to queue, compared to array, okay, compared to stack, queue is harder, okay. So if you want to implement a queue by using array data structure, so this will be a little bit difficult than the stack, okay. So the reason is the same reason, because stack you want to insert or remove an element, it will be only one end, the top end you are going to insert and you are going to remove. But in case queue, if you want to insert an element, you can insert one end, and if you want to remove, you can remove from the another end, okay. So that's why there will be a bit difficulty is there to implement the queue by using arrays, okay, than stack data structure, okay. Similarly, if you want to implement, okay, there are two options for implementing queue using an array. So one option is like NQ, like you need to insert data of 0. Okay, for NQ the operation is similarly, if you are, this is array. Okay, so array is set of, this is array representation, data of 0. If you represent like this will be the NQ, then DQ will be like data of number of items minus 1. Okay, so this is another array with DQ operation. If you want to delete something, you can delete. Okay, the next option is like, if you want to using the standard notation like this, you just follow this one, data of 0 and data of number of items minus 1. Okay, so there is option 2, like I said there are two ends will be there for Q. One is rear and another one is front end. Okay, so if you want to insert anything, you can call that end. Okay, data of rear plus 1, you can do NQ operation. DQ means, so DQ at data of front. Okay, so this will be the front, this will be the rear. Okay, so this rear plus 1 is used for inserting. Rear plus 1 means this is rear end. If you are incrementing one thing here, rear plus 1 is, this is the place. Okay, here you can insert one element. This is the front end. Whenever the job is done, you can remove. Okay, so like this front end and rear end. Rear end is used to insert the items in the queue. Front end you are going to use delete items from the queue. Okay, now see, so that's the representation. You can represent like this, either rear or front end. Okay, this is the option 2. Which method you want to follow means that's up to you. Okay, whether you want to use rear and front terminology or the normal terminology, data of 0 or number of items minus 1, you just select it. Okay, so generally rear variable always contains the index of the last item in the queue. Okay, I said, okay, rear means the last item or last person in the queue. Front variable contains the index of the first item in the queue. First means I already showed. Okay, when we reach the end of the array, so you write the data structure. Okay, this is the like the normal data structure. You can assign front and rear like this. Anyhow, um, this is not Python. Okay, this is like some Java programming. I will demonstrate, or I will show you the Python code how to define stack and queue data structures by using arrays and all. Okay, so we will see those hands-on session or hands-on demos a little later. Okay, now okay, this is about stacks and queue, a brief introduction. So now I will show some more examples. See, I will give some more details. Okay, see, this is stack and queue. Like if you take stack and queue, there will be some basic principles will be there in both the data structures, here and here. Then there will be set of operations, like here push and pop, here NQ and DQ. For insertion, okay, you are going to call push and pop. Okay, similarly stack using array, you can implement the stack data structures by using array. Similarly, you can use queue data structures by using array and linked list also. Okay, then we will see few applications one by one. Okay, first we will see stack. Okay, see, this is the basic idea of stack. Okay, see, in this example, these are some set of cups or something. Okay, you can place one by one cup, second cup, third cup, fourth cup, fifth cup. Otherwise, this pack of cards or deck of cards. Okay, so this is the stack data structure. Okay, already we discussed this thing. I'm just showing some more basic details. Okay, when it comes to stack representation, you can represent like this. So this is push operation. You just observe this arrow. If you want to insert any elements or items. This is the stack. You can graphically or you can represent stack like this. You just assume this is a rack. Okay, you are trying to insert element. Okay, this is push operation. If you observe, this arrow will be like this. This is removing. Okay, so this is pop, last in first out. Okay, so this can be implemented by using arrays, structures, pointers and linked list, but the most familiar one will be arrays and linked list only. Sometimes if you want, you can use structures and pointers also, but the structures and pointers, it will make more confusion and it will take more time also, okay, for implementing. So these are the simple data structures, array and linked list, so you can able to implement stack very easily. Okay, again I am telling this stack size. Okay, initially you need to define. For example, if you say my stack size is 1 2 3 4 5, so that is fixed size. Okay, like static, the name is static or fixed size. So sometimes there will be dynamic. Okay, if you allocate more memory to the stack and you are not telling how many items you need to insert, okay, don't specify or don't fix the size of the stack. Okay, the stack capacity may be infinity or some kind of thing n, then you are going to call it as dynamic stack. Okay, so these are the different operations you can apply on stack. Push, pop, create, is empty, is full. Okay, push means I already told you want to insert element to the stack, you can call it as push operation. Pop means you want to remove an item from the stack or you want to delete. Okay, that is pop operation. Create means, see, from program you want to do, right? See, for drawing this is easy. Okay, like if you want to draw this kind of structure by using pen and paper, okay, you can create. Okay, you can create this kind of stack through program. If you want to do means, there will be some keywords are there. Okay, like you can create, you can use create function to create the stack, it will create it. Suppose if you want to empty the stack, you can use isEmpty function to isEmpty it. That means empty the entire stack. Is full means if you want to full. Okay, so these are the different operations or functions you can perform on stack. This is normal C syntax. If you want to push, you can write like this, push, and later we will see Python code also. Pop means pop off that stack. Okay, create means you can create like this, it will create the new stack. Then is empty means it will check, okay, if the stack is empty or not. Okay, so if this is empty, then it will allow you to insert the element. Suppose if it is full, then it won't allow. Okay, for checking whether the stack is empty or not, or if this is full, you can use these functions, is empty and is full. So now come to here, stack using array data structure. So how can you implement this one? So this is stack, this is the pointer like top of the stack. Suppose if you want to insert one element, for that you are going to use push operation. So you are trying to push it, and then this top, okay, top means the top position, it will increment to the next place. Okay, so initially the top is here. Once you inserted one element, the top position will be incremented and it will show the present stack of the, the present pointer or the present top of the stack. Okay, so then you can insert one more element. After that, what it will do, so now you inserted two elements. This is one item, you assume that this red color box is one item and this is another red color small item. Okay, now you want to pop it. Okay, what it will do, so it will pop by using pop operation, you can pop it. So again you can do. Okay, you can repeat this procedure like this push and pop operations by using top of the stack. Okay, so that is the position, or what you are going to call it as holder, to hold the current status or current position of the stack. For that you are using one holder, that is top holder. Okay, so if you want to implement stack by using linked list, okay, this is the procedure. Okay, so like these are the nodes. Okay, there are different nodes, these are linked. Okay, these are the links, you are going to call it as, like this is the list. Okay, in this list there will be some items will present. Okay, for example there will be some numbers are present, this list is connected, that's why the name is linked list. So this list is connected through some links. Now this is the top. Now you want to insert one item. Okay, so you can insert that item like this. Okay, so once insertion is over, the top, it will, this pointer is connected to the inserted item. Okay, so now one item is inserted. Then next, what you want to do, if you want to pop, you just remove this. This is the new item inserted. If you want to remove, you just remove. Okay, then this pointer is connected to the this thing. Whenever a item is removed, okay, these links are disconnected, and again you are going to connect it to the other nodes. Okay, so always you need to maintain the links properly. Based on that links or connections, you are trying to work on push and pop operations by using linked data structure. Okay, linked list data structure. So the basic idea mm, for array implementation. Okay, so what is the main difference between see here array and linked list? Okay, initially you need to declare the array or fixed size. Okay, if you know the um, array size, then you can go for array data structure. That means size of the stack, you can prefer array. Suppose if you don't know the size of the stack, then you can prefer the linked list. Okay, so that is the main key difference between. So these are the like C program to declare or to define stack. Okay, so in C there will be struct will be there with the help of structure. So they are trying to declare queue like this. Okay, stack creation, these are the C programs. Okay, I don't know whether you know this or not. Can you please, someone will respond, you know these things?
Yes, sir, we know this.
Oh, okay. So what is the main intention is, I will discuss uh, this stack and queue data structures using Python. Okay, because our course name is like programming and data structures using Python. So I will show you how to implement um, this stack and queue by using Python. Okay, so anyhow you just recall these things. um, okay, these are the applications of stack. Again, some new applications are there: validate XML, undo sequence text editor. um, I will just show these applications briefly, and then we will move on to implementation of stack and queue by using Python. Okay, so this is like infix to postfix. Like I already discussed. Okay, so one of the best example for our application for stack is infix to postfix acceleration. Infix means, in means in between two operands there will be some operator will present. Okay, this is called infix. In between it is present to the operator. Post means the operands are there, the operator will be present after the operands. Okay, so this is operator, these are the operands. Okay, the terminology is A and B are operands. So plus or any kind of symbols. Okay, you are going to call it as operator. Okay, so if you represent like this, this is infix, this is postfix. Okay, so whenever you want to convert infix to postfix form, stack will be the best data structure. Okay, so there will be set of rules are there. First, initially you need to insert one by one. For example, a plus b is there. You want to insert this a plus b in the stack. Okay, what you will do is initially you insert a, then whenever the operator will comes into the picture, you need to remove it. Okay, you need to remove it. Then again you place the b. Okay, so like this some set of rules are there. This will be the best applications. Okay, okay, so these are the algorithm steps whenever you are having this symbol or parenthesis. Okay, so I will explain this one. Okay, so this is the expression a star b plus c star d plus c. What you want to do, this will be the infix expression because the operators are present in between these operands. What you want to do is you need to convert this into postfix. This is the postfix expression. So how this will work? Okay, so initially the current symbol is, you just assume that this is initially you need to push this one. Whenever the next symbol is star, this is operator. When operator comes into picture, so you just try to remove the try pop from the okay, you will get the postfix string is a. Similarly next is operator, the same thing will be there. So the next is b will come, b you are going to insert it. Whenever plus thing will come, you just uh, pop the b from the stack, then you should represent a b. Okay, so like this you repeat the procedure, so until there will be no operands are present in the expression. So at last what you will get is you will get the a b c d. Okay, then you will get um, the set of operators. Okay, so this is similarly this is the q. So q also there will be operations like push pop, there will be enq, deq, create is empty and size will be there. So what this will do is, this is the like the same way. Okay, NQ is used to insert the element, DQ to remove the element, creation of new Q, then is empty. Okay, so the same thing. Okay, so Q also you can implement the same way. Now, okay, anyhow we are not interested in C programming. Okay, so I will start or I will show the queue and stack data structures by using Python. Just how to implement this. So now see, we will see. Okay, Python stack is data structure that store the data, um, like stack of plates in the kitchen. You are trying to place plates in the kitchen. These are the different plates. One by one you are going to example. This will be the example. I think you already know these things. Data items or data elements in the stack can be inserted at the one end. This is push and removed another end pop. Then the last data element can be read from the stack, that is peak operation. Okay, these are the different operations. See here, Initially I told stack data structures, it will allow us to store and read data from one end. It will work in last in first out fashion. Okay, there is another name also called last in last out also. Okay, just remember, queue is first in first out. There are two names, last in first out, or you may call last in last out. Okay, so the stack will follow this thing. Okay, there are two primary operations like push and pop. When an element is added to the top of the stack, you are going to call it as push item, push operation. When you want to pick up or you want to remove, okay, pick up means like removing only, that is called pop operation. Okay, so this is the example. Push the elements to the stack. There will be 5 elements are there. This is peak in the data frame. Peak means peak always represent the top of the element that is present in the okay. Come to here. Okay, this will be the table. If you want to represent stack operation, stack of you can represent parentheses. Suppose if you want to represent size, okay, this will be 0 1 2 3. Okay, the contents you can use the, this will be stack operation. So if you represent like this operation is, the stack object is created, the size of the stack is 0, there will be no contents. See here, there will be no contents. Okay, so now what you want to do, initially you created, now if there is no contents, you need to insert items. So here I am doing push egg. We are inserting one item, egg item. Okay, then you can write like this. If you want to apply push operation, the contents you can write like this: one item egg is added to the stack, then push ham. So then this will be egg plus second item. Okay, so one more item is added to the stack. Similarly, peak means it won't insert, the size is same only, but what it will do is it will represent the top. Can you tell me which one is the top element? So the top element is ham, it will return it. Okay, similarly if you want to remove, you can remove pop like this. Okay, so this is push pop operations. We will see see here. Okay, I will explain this code, the Python code. Okay, the previous example whatever I discussed now, so this is the example. Okay, stack, initially it is 0, then you just, if you want to insert egg, you insert it. Okay, then second element, then if you want to insert third element, you can insert, otherwise if you want to remove. Okay, this will work like this. So now come to Python code. Okay, initially if you want to, for this example I am just discussing Python code. Initially size 3 means we are going to have two different kinds of stack. One is static stack, another one is dynamic stack. Okay, so if you give size of the stack now itself, this is called static stack. So you are allowed to insert only 3 elements only. Okay, so then you are trying to initializing the stack. For that, in Python you need to write like this data is like data item. Okay, so initially 0, later you are trying to add. Okay, for data item, like data of top, you are trying to add the items. Okay, so initially this top will be -1. So -1 is nothing but there will be no items. This is empty stack. Okay, -1 is nothing but 0 means there will be 1, that size initialized in the stack. If -1 means, so there will be no items. So this is empty stack. Okay, then you want to, if whenever the stack is empty, what you want to do, you want to insert the element. For that you need to write a push function. I think you already know in Python, if you want to define any function, you can use the define keyword, def keyword, and then push function. Then you can write okay, top top is like global variable. Okay, there are two different things, one is global and local variables. So again here we are defining global thing. So if top is greater than that size of -1 means size of the stack. If top position, the point of top position is, this is the top position, if it is greater than size -1, okay, then stack is overflow. What does this meaning is, for example here in this example top is, it is representing 0 or this pointer. Okay, you assume that there is one element is here, top is 1. Okay, so then size of -1, okay, stack size is 3, 3 minus 1 is 2. So in this case there will be two elements is possible, you can insert it. But if you take here top is 2, that means top is representing the third element, so the top value is 3 here. Then size of the stack is 3 minus 1, 2. So now 3 is greater than 2. So in this case stack is overflow, so you are not allowed to insert element. So if stack is overflow, you are not allowed to do any insertion. So then else case, okay, in this case this is not true because top is less than only initially. It will go for else, then it will add items. Okay, then it will increment it. Once one particular element is inserted into the stack, then you can increment the top position. Okay, like top equal to top plus 1, it will change the like this one. Okay, top plus 1 means initially your top is this one, top plus 1 means it will represent the next position. Okay, so after one particular element insertion. So these are the syntaxes. Okay, just try to remember, you need to write a Python code like this. Suppose if you want to insert any element, okay, so like what we are doing is in this code, okay, in this this is the explanation. Okay, in this code we are initializing stack with fixed size 3 in this example. Okay, in this example the fixed size is 3, and also top pointer we are trying to top pointer to -1, which indicates that if it is -1, okay, what you are going to call it as, the stack is empty. Further what you are doing, you are trying to push. So this is your push operation. Push method is used to insert the elements. So this function will call this push, it will insert these elements. Okay, push of egg, ham, spam. Okay, this will be used to insertion the elements in the stack. Okay, so if there is 3 elements are already inserted, you are trying to insert one more here. Whenever this is true, then it will show the error message like stack is overflow. Okay, so that is the stack overflow message is printed. If the stack is not full, then the top pointer is incremented by 1. The new data element is added to the top of the stack. Okay, so this will be the code for this one. Okay, like you need to insert data elements. Okay, now pop. So here push happened, 3 items you inserted like this. When it comes to pop, you need to remove one by one. Okay, so the same thing, but in previous case it's stack overflow. Now what you want to do is, so instead of overflow you will get the underflow. You want to increment the stack, instead of incrementation one by one, you need to decrement the stack. Like previously top equal to top plus 1, in this case top equal to top minus 1. Okay, so whenever data of top is 0, okay, then you need to return the top of this element. Okay, so like this you can apply push and pop operation. There is another operation, anyhow, peak operation. What it will do is, it won't insert or remove, but whatever the top element that is present in the stack, it will return that element. Okay, just for returning the what is the current top value in the stack. If you want to know that one, you can use the peak operation. So this is the you can write a Python code like this. Okay, so these are the functions like push. Def means you need to write separate functions for all 3 operations like push, pop and peak. Okay, so if you represent like this, data of 0, data of n-1, I said okay, this is by using array data structure. Now come to here, that stack implementation using linked list. um, using Python. Okay, so for this what you want to do is, in order to implement stacks using linked list, okay, so you need to use a concept called class. Okay, like there is a stack class is there in Python. Okay, you can define the nodes, linked list nodes. Okay, class node, then you need to initialize that node. Okay, generally the initialization is self referential, it will reference the self. After that, self dot data, then you can assign some kind of values. If self dot next equal to, okay, this is like self installation of a particular node, only one single node. Okay, so then I think if you know the linked list concept in data structures, then you will get to know this Python code. I hope you know the linked list concept in data structures. You know, or okay, this is the Python representation for defining a one node. Okay, so similarly, if you want to repeat a number of nodes, you can repeat. Okay, so this is the representation. See here, there will be two fields are present in the linked list. One is data, that is your actual element. Next means the next value, like in stack there will be different data elements. Okay, the next is used to connect or link the next data item. Okay, so this is the representation. You can represent stack using linked list like this. Okay, representation of the stack using. So we first need to know which node is the top of the stack, so that we can do similar push and pop operations. Okay, like see the same thing. See here, um, previous case only one data element is there. The same thing you can by using this kind of structure, you just connect the links properly, then you can insert the elements. Okay, this is working of push operation. So initially stack is empty, and then you want to add a new node to be added to the first element. Okay, we need to make this node as top of the node element. For that, what you are doing is you can use self. So this is initially empty stack. You want to add one element, egg element. This is new data element. Okay, this is your top pointer. You just add it, the next pointer. Okay, generally it will represent none. Okay, self dot stop will point to the new node. Okay, this is the self dot point. Okay, see the figure. This is the insertion of a data element egg into the empty stack. One item is inserted. For this, if you want to write code, you can write like this: def push self comma data. This is push function. Okay, for creating a node, you can call like this: node equal to node of data. Then if self dot top, then what you want to do is the next node dot next. Okay, the next will be, this is the next. Okay, this will be represent the next top position. Okay, so then self dot top equal to node. Okay, else the next case is if there is no, I mean, next pointer, then it will go for else case self dot top. You can assign the node value to the top position. Okay, you can increment the size of this um, list, linked list. Okay, this is the concerned code for the inserting an element in the stack. Okay, so after that you can create a stack of data elements like this. Okay, so you can print those stack of elements. This is called, okay, this procedure is stack. Similarly push operation, like you are inserting, similarly pop also. Okay, so this will be the this will be the pop thing. Okay, so like this you can implement push pop operation in stack and queues also. Mm, what we will do is we will see few examples. So I will show some. We'll see one or two examples by using Python. Okay. So we will see small examples how to do this push and pop operation. Okay. Um, by using Python and all. Okay. So what I will do is I will take some code. Okay. And I will explain. Okay. So what I am doing is I am taking some code for explanation as and I will explain. Just give me a minute. So I am taking one code and I will explain this one. Okay. So initially you need to implement stack by using array. So what you want to do is I will explain this code. Okay. Okay, come to here. Okay, suppose if you want to declare stack data structure. Okay, like LIFO, FIFO, there will be different operations: push, pop, and peek. You can represent class of stack. This is function. Then you can define the capacity of that stack. Okay, you can write like this. This is init means initialization. What it will do is it will initialize the capacity of the stack. Capacity, if you call capacity, means it will define how many elements the stack can hold. Okay, the maximum size of the stack, that is self start capacity. So initially it will be none. Okay, there will be no values. None means this is fixed size array. Okay, so index of the top element initially you need to assign to -1. -1 is nothing but it will show the top position of the stack. Okay, so there are different functions. Okay, like I told, is empty. So if you want to check whether the stack is empty or not, okay, you need to call this function is empty self. Okay, this is the self, this is self stack. Okay, um, so if you call this function, if it will return -1 means, so that is the meaning it is empty. Okay, suppose if you call this function, if it will return, okay, something else, okay, self dot capacity -1, then it is full. Okay, so if it is empty, then what you want to do, your next job is you need to insert some elements to the stack. You need to go for push operation. Okay, so then you call, you can define push self com item. So it will check this condition whether the stack is full or not. So in this case, if it is empty, it will go to the else part. Else part means you are trying to add elements. Okay, self dot tag, then you can increment the top position, you insert. Okay, like you are trying to push some items. Okay, so if this is full, then it will return this message. Okay, stack is overflow, you cannot push any item. Similarly for pop also. So the same thing. Similarly, peak is there, then display. So whatever the elements you are there, you need to display those items. You can display. For example, in this example, see here the example. Okay, they are trying to push different elements. Stack of 5. Okay, this stack size is 5. S equal to stack of 5 is nothing but stack size is 5. So the maximum capacity is 5. Then what we are doing, we are trying to S dot S means this is okay. The S dot push of 10 means you need to insert 10, the next element 20, then 30. So after 30, what you are doing, you are trying to display. You inserted 3 elements. You check here, pushed 10, 20, 30. Then display function you are calling. S dot display function means. So if you call this function, it will go to push and it will insert it. So if you call display, it will display the elements that are present in the stack. Then after that, peak, what peak will do, so this is peak is the top element it will return. So in this example, the top element is 30. Then again you are calling after display, sorry, after display peak you called, then pop also. Pop means it will remove that 30. Okay, so it will remove pop, the 30 is popped. Okay, then after 30 is popped, then what you are doing, so now it is removed, you removed 30 from the stack. Now only two elements are present, but stack capacity is 5. Okay, again after that they are trying to insert some more elements, 40, 50, 60. Okay, so here already two elements are there, you can able to push 40, 50, 60. Then 60 also they are trying to insert. Okay, whenever you are trying to insert or push, then there will be some overflow error, it will occur. Okay, this will show, then you display the elements. See here, if you are trying to insert, already in your stack 10, 20 is there, 40 you pushed, 50 you pushed, and 60. Whenever you are trying to push 70, then there is overflow occurred. Okay, so whenever the overflow occurred, you can't able to insert, then you are calling the s dot display. It will display all the elements. Okay, whatever the stack size is 5, um, it will display it. Okay, so these are the current stack elements. Okay, like this you can implement stack by using different functions. Similarly, this will be applicable for queue also. Okay, so you can practice different examples by using Python code. Okay, this is like you are using this structure. Okay, this is array implementation. Okay, so this is array implementation. So I will share you linked list also. I will explain linked list also, then we will see. Same thing, but don't represent this format, stack of something. Okay, here you will get the some nodes. Okay, so this is the code for linked list. Just check this structure. Okay, stack implementation using this is the representation. If you want to represent node structure, you can write like this. Like previously class stack is there, but here node is there, then the representation is slight different. Okay, you need to self representation of data, and the next pointer will come. So only difference is you just see this structure. Okay, like you need to create the node. For creating the node, you can call like this, node of data, then you can link the new node to the current top of the stack. Okay, this will represent the current stack of the core stack. If you want to update, you update the top like this. Okay, these three statements you required. Okay, um, generally data node is going to store the actual value. Next node is you need to refer, or you need to point out the next node. Okay, so like this I will share these codes. Okay, you just go to my folder, and then you can explore and you practice these things. Okay, similarly I explained stack by using arrays and linked list. You can practice queues also by using arrays and linked list. Okay, so that's it from my end. Okay, so if you have any questions, you ask me. Okay, otherwise I will end the session. Any questions? Okay, if you don't have any questions, I will stop here. Okay, we'll continue in next week. Thank you.